So what we really want to know is if you mix a combination of chemicals together, will they do a reaction? And we want to know this kind of, or at least have a good guess on it ahead of time, because you don't want to waste money on chemicals if they're not going to react, and you don't want to waste time and effort of your day trying to do something that isn't going to happen. So we have tables and tables of charts and values that will help us make some guesses as to if we think something's going to happen. If you mix any combination of chemicals together, like any of them in water, will they react? Like, think about if you were to take, I don't know, oil and vinegar, or just two kinds of different oils, and you mix them together. Do they make something new? Can you always mix things together? Like, can you take oxygen and can you mix it with carbon dioxide? Does it make something new? The answer would be no. Sometimes they do, sometimes they don't. And it all comes down to energy and what's going on with the energy in the reaction. Now, I'm going to mention something that comes up in Gen Chem 2. So these two little words right here, they are not going to be on a test or anything. But I'd like to do a quick preview because sometimes people get confused. We'll talk about things like driving forces, and enthalpy is related to heat energy. And entropy, I don't know. Sometimes we call it disorder. There's another definition for this. Sometimes we call it kind of leftover energy. But it's a different kind of an energy. These two things, sometimes they both work together and they form a driving force, and then sometimes they fight against each other and one of them wins as a driving force. So these are called driving forces. If they both are happy, if the enthalpy is working and it's the main driving force, it just means that everyone wants to give off heat. That's kind of the state of what things want to do. And then for entropy, everyone wants to go crazy. They want to be able, they don't want to be constrained, basically. They don't want to be stuck in a little solid, like just jittering around. They want to be able to be free to be gases and move around the molecule. So a lot of entropy is about kind of like becoming a gas. There's more to it than that. So those are the driving forces. That's going to come back Gen Chem 2. However, for now, we have kind of a summary, and we're kind of over-summarizing just for the purposes of Gen Chem 1. So, will a reaction go? Here's the yes category, and here's the no category. If you make any gas, the reaction will go. And by the way, that most likely is an influence of entropy. It could have enthalpy helping it along too, but that's probably going to be more entropy. If you make any gas. If you make water as a liquid, that also is going to go. That could be entropy or it could be enthalpy. Those two, in that case, it's a toss-up. It depends on the reaction. And then lastly, if you make a solid. Now, you're going to find out that making a solid in Gen Chem 2, you'll find out this is more related to how much heat is given off. But we're just going to summarize it and say, if you make a solid, it's a driving force on this in this part of Gen Chem. And we're just going to be a little more specific in Gen Chem 2 when we get to it. So these are three things you want to look for. You want to look for these three phases, a G, an S, or an L. So how do you know when you're not going to? All right, when you have an AQ, this almost always means that you are not going to have a reaction. The only exception that will go is if you make H compounds that are insoluble. Well, the word isn't insoluble, but that do not dissociate. So we're going to talk about that case coming up. Do not dissociate. And this is very uncommon. I don't even know if we're going to give you an example of it coming up. Whoops. But this is the main thing you're looking. I keep grabbing that. This is the main thing you're looking for. You're looking for an AQ. If both things you make is an AQ, it means everything is just floating around as an ion and nothing's joining together or forming anything. And it's just all in there being like charges floating around. To make one of these three things, they have to get together and actually form it.